Assalamualaikum students. Today we will discuss the topic of chapter number 3. Our chapter name is Dynamics. This is your first video lecture. So before discussing our topic, you must know that what is tension. For this, you have to consider this diagram. As you can see, that block of wood is hanging with the help of the string with that stand. The weight of the block is acting in the downward direction, and due to that weight, the tension is produced in this string. The block pulls the string downwards by its weight, and this causes a tension T in the string. The tension T in the string is acting upwards at the block, and as the block is at rest, therefore the weight of the block acting downward must be balanced by the upward tension T in the string. Thus the tension T in the string must be equal and opposite to the weight W of the block. So here we are considering that weight of the block and tension are equal but in the opposite direction. So we can consider them as action and reaction. So we will find the tension and acceleration in the string. This topic is on the page number 64 in your book. So this setup in the figure is called Atwood machine. What is an Atwood machine? An Atwood machine is an arrangement of objects of unequal masses such as shown in the figure. So block A and block B have different masses. So block A have mass M1 and block B have mass M2. So here we can say that both of the objects are attached to the ends of a string. The string passes over a frictionless pulley, and this arrangement is sometimes used to find the acceleration due to gravity, which is represented by small g. So here in this setup, the pulley is considered as frictionless because we want no effect of any other force on the motion of these blocks. So we will consider this pulley frictionless and this string weightless. So here the start of our topic, vertical motion of the two bodies attached to the end of a string that passes over a frictionless pulley. So here we have two blocks and they are moving vertically. So one block have weight W1, which can be written as M1G, and the second block have weight W2 is equals to M2G. This relation is not written in your book, so we have considered it because we know that weight is equals to mg. So the weight of the first block can be written as W1 is equals to M1G, and weight of the second block can be written as W2 is equals to M2G. So after that, we will write the Newton's second law of motion. Newton's second law of motion said that force applied is directly proportional to the acceleration produced in the body, and F is equals to ma. So F1 is equals to m1a and F2 is equals to m2a. So F1 is equals to m1a is Newton's second law of motion for block A, first block, and F2 is equals to m2a is the force or the Newton's second law of motion for the second block, block B. After that, we have to identify the direction of the motion of these blocks, that which block is moving in the downward direction and which block is moving in the upward direction. As from the figure, it is clear that both of the blocks are made up of the same material, but block A is larger than the block B, So we can write that m1 is greater than m2. So block A is moving in the downward direction and block B is moving in the upward direction. The motion of both of the blocks is along the y-axis. So for these blocks, we have to find the acceleration and the value of tension in the string by which these both blocks are attached with each other. As the string which is attached with the both of the block is one string and both of the blocks are attached with the opposite ends. So if one block will move in the downward direction, the other will must move in the upward direction. So since the body A moves downward, here, so its weight is W1 is equals to M1G is greater than the tension T in the string. So as in the first or second slide, you see that the block was at rest because there the tension and weight was equal and the weight was in the downward direction and tension was in the upward direction. You can see this in the diagram 3.11 on page number 64. So in this case, weight was not moving. So tension and weight was equal there. But in this case, weight 1 and the tension in the string are not equal. Weight is moving in the downward direction and tension is not enough to make it static. So now we will find the net force acting on a body A, which we can write F1. So the total forces acting on the string and the block are weight of the block and the tension in the upward direction. As the weight and tension both have opposite direction, so one of them will be considered negative. Here tension is considered as negative. Why? Because tension is less than the weight. Weight is not balanced by the tension and tension is not enough. Tension is very smaller than the weight. That is why we can consider tension as a negative. The small force will be considered negative. So according to the Newton's second law of motion, F1 is equals to m1a. So by comparing these both equations, as their left hand side is equal, so we can equate their right hand sides. So we can write m1a is equals to m1g minus t. So write this equation as 1 or 3.6 in your book. This equation is 3.6 in your book, but I write it as first equation. As body B moves upward, hence its weight is W2 is equals to M2G is less than the tension T in the string. So in the block B, tension is greater than the weight. So that's why weight will move in the upward direction. So for the second block B, we will consider T as a positive because it is greater than the weight, and we will take weight as a negative. So T minus M2G is the total force acting on B. So this is the sum of all the forces. But why there is a negative sign? Because one force is greater and one is less, and negative sign is showing the direction, opposite direction. Tension and weight are applied in the opposite direction. That is why one force is negative, considered as negative, and one force will be considered as positive. So according to the Newton's second law of motion, F2 is equals to T minus M2G. Because F2 is equals to M2A, so we will compare both of the equations and we can write M2A is equals to T minus M2G. This is your second equation, and in the book this equation is 3.7. So our mathematics is not complete here, but now we are at the stage that we can calculate the acceleration and tension for this setup. So we will add first and second equation. So left hand side of this equation, equation 1 and equation 2 will be added, and right hand side of the equation 1 will be added into the right side of the equation number 2. So here m1 and m2 have the same multiple a. We will take a as a common, and here t positive and t negative will be cancelled, and m1 and m2g have the same multiple g. We will take g as a common. Because we have to find acceleration, so we will divide m1 plus m2 on both sides. So we will get the final expression for acceleration as m1 minus m2 divided by m1 plus m2 into g. For finding the tension, we will divide equation number 2 by equation number 1. So left hand side of the equation number 2 will be divided by left hand side of the equation number 1, and right hand side of the equation number 2 will be divided by the right side of the equation number 1, as I have done here. After that, we have to solve this equation for tension T and T. T is here in the numerator and T is here in the denominator. So we have to solve this. So by cross multiplication, M2A will be multiplied to M1G minus T, and M1A will be multiplied to tension minus M2G. Here are the explained steps. So M1, M2, AG and M2 AT is equals to, you can multiply M1A by T and M2G. So this is the final expression. After that, we can change the sides. So I have write M1 M2 AG on the left side and M2A into T on the right side. As both were negative, so by changing their sides, they become positive. So from the left side, we have same expression. So after adding that, we get 2 into m1 m2 ag, and on the right side we have acceleration and tension as common, so we left with m1 plus m2 into the brackets and at as a common. So as we have to find the value of tension, so we will divide this value acceleration and m1 plus m2 on both sides. By dividing, we will get the final expression for tension. This is the final expression for the tension. So by that calculation, we have find the expression for acceleration and tension for the vertical motion of the bodies attached to the end of the string that passes over the frictionless pulley. So after that, you have to do that assessment. Derive the formula for tension and acceleration in a string for a vertical motion of two bodies attached to the end of a string that passes over a frictionless pulley. So you have to practice it and write it on your notebook. So for more explanation, you can also practice the example 3.4 and your numerical 3.6. This example is on page number 65 and numerical 3.6 is on page number 83. So I will explain you both of these example and numerical. So write the statement. Two masses 5.2 kg and 4.8 kg are attached to the ends of an inextensible string that it is not extendable. A string which passes over a frictionless pulley. Find the acceleration in the system and tension in the string when both of the masses are moving vertically. So you have to find the acceleration and tension of the system, and this system is of vertical motion. So you for finding the acceleration and tension, firstly you have to write the formulas as we have derived before. m1 minus m2 divided by m1 plus m2 into g, and tension is equals to 2m1 m2 divided by m1 plus m2 into g. So here, as you can see that in the formula, you just need masses, the values of masses, and you are given with the mass m1 and m2. So m1 is given m 5.2 gram kg, sorry, and m2 is equals to 4.8 kilogram. So simply you have to put these values in the place of m1 and m2, and you have to solve this. You will get 0.4 meter per second square acceleration. So it means that there is 0.4 meter per second acceleration in the string. And what is the tension? Tension, you can find the tension by this formula. Put the values of m1 and m2 in the formula of tension and calculate it. You will get tension is equals to 50 newtons. So thus the acceleration in the system is 0.4 meter per second square, and the tension in the string is 50 newton. So numerical number 3.6. Here you are also given with the masses. Two masses 52 kg and 48 kg are attached to the end of the string that passes over frictionless pulley. Find the tension in the string and acceleration in the body when both of the masses are moving vertically. So again, this is a vertical motion case, and you can find the tension and acceleration by using these formulas we have derived before. So simply put mass 1 and mass 2 in these formulas and calculate them, and after calculating you will find that tension in the string is 499.20. You can write it approximately 500 newton. And acceleration, you can find acceleration by using this formula, m1 minus m2 divided by m1 plus m2 into g. So put m1 as 52 and m2 as 48 in the numerator and denominator and multiply it with the 10. After solving, you will find that there is 0.4 meter per second acceleration is produced in this system. So this is today's lecture. In the next lecture, we will discuss the second case of the tension and acceleration, in which one mass is on the horizontal surface and one mass is moving vertically downward.